This morning, I made the exam one viewing available. So if you go to the website, then you will be able to see which one you did incorrectly. And if you want to see the correct answer, then there is a answer key button on the top left corner. So you can press that, then you will see the correct answer, and you will see how to correct your wrong answer. Do you have any question? Okay, then we will continue with the graph of y equals secant of x. I said, if you go to the website, then you can see the exam one. No, what I'm saying is if you got wrong, if you are marked with wrong, then you will be able to see the correct answer by pressing the answer key on the top left corner, so that you can correct yourself about after you know what problems you did wrong and what the correct answer is. Do you have any other question? There is nothing wrong with the exam problem. So let's continue with graph of y equals secant of x. Secant of x is defined as 1 over cosine of x. So whenever cosine of x becomes 0, this fraction will be undefined and the secant value will not be defined there. So domain will be all real numbers except where the cosine value becomes 0. Cosine becomes 0 whenever that is odd multiple of pi over 2. In the unit circle, whenever the x value equals to 0. So that is something to do with y-axis. So that's the reason it becomes odd multiple of pi over 2. Whenever that is undefined, we have vertical asymptote. The equation of the vertical asymptote becomes x equals 2n plus 1 pi over 2 when n is an integer. When we graph secant, what we have to do is we will draw the graph of cosine, and then we will think about what is the reciprocal function's graph will be. Let's draw the cosine function first. cosine is bounded by 1 and -1. The benchmark happens every pi/2. We are considering cosine function, so we start at the maximum value. This is the graph of cosine. So y equals cosine of x looks like this. I said whenever cosine becomes 0, secant function will have vertical asymptote because 1/0 is undefined. So we will draw the vertical asymptote whenever cosine value becomes 0. And then we will shape the secant function. That is 1/something. So what I told you is if a cosine x is like 1/10, 1/100, 1/1000, and so on, it gets smaller and smaller. Then what happens to secant? Secant of x is the reciprocal of these numbers. So it becomes 10, 100, and 1000, and so on. When we visualize that, what happens here is that when that is 1/1 is 1. So they will share this point. But when cosine value gets smaller and smaller, approaches 0, as you can see here, secant value will get larger and larger indefinitely. And this is a vertical asymptote. So what should happen will be, it will be just a flip shape, but it doesn't cross the vertical asymptote because when cosine equals 0, secant is undefined, right? So you can reason it naturally. So with the same reasoning, this is -1. 1/-1 is -1, so they will share this point. But with the same reasoning, it'll be the flipped shape with the obvious vertical asymptotes like this. So we can see that the secant of x is not connected. Those are not connected, and just a flipped shape of cosine. But period of secant of x is 2 pi, because period of cosine is 2 pi, and 1/something is secant. 1/cosine is secant but the period should be the same, right? The period is still 2 pi, and the range is from negative infinity to -1, union 1 to infinity. Because of this, so that is greater than or equal to 1, that is included here, and that is less than or equal to 1, and that is here. Cosine function is an even function, so secant is an even function. What does that mean? Secant of negative x equals secant of x. Why is that? Because when you flip along y-axis, the right side and left side will be completely overlap each other. So when we switch the sign of x value, y value will stay the same as the original one. That's the meaning of even function. So let's do some example. Yeah. Here. Here. Yeah. Yeah. If something is multiplied to x, of course, a period will be adjusted, and so that is 2 pi over something. Yeah. Yeah, right. Any other question? Let's do the example which is related to your question. Find the period of y equals 4 secant of 2 pi x and graph it. We want to calculate the period first, as we did, and then we will think about the key point, but we will not think about the amplitude because that is not bounded. So period is 2 pi over this number, 2 pi. That equals 1. That means key points will become 4 points between 1, 0, and 1, which equally divide the interval. So 1 over 4, and then 2 over 4 is 1/2, and then 3 over 4. The other thing you have to notice is there is 4 multiplied to secant. What does that mean? That means Yeah, amplifier, right. So amplifier, yeah, so but in this case, maybe it is interpreted as a vertical stretch because we don't think about the amplitude and secant because it just go without bound, right? So that is a vertical stretch. So how that affected? So this one, so amplitude affected maximum and minimum. This vertical stretch for secant will affect the maximum and minimum. So what the local maximum and local minimum. So what is local maximum? Local maximum will be 4 because the cosine values maximum is 1, but 4 is multiplied. This is 1 over cosine. The maximum was 1 over cosine, but the cosine is 1. So local maximum will be 4 because 4 is multiplied. Local minimum becomes -4. So these are the points we have to think about. So the first thing I will do will be drawing the cosine function, and then I will flip after I draw the vertical lines for the vertical asymptote. So we will combine all those information. So it should be pretty long graph. It should be above 4, 1, 2, 3, 4. And then the graph will be located above 4 and below -4. And then the benchmark happened every 1/4. So it goes like 1 over 4 and 1 over 2 and 3 over 4 and 1 and 5 over 4 and -1 over 4 and -1 over 2 and -3 over 4. And then we know that the cosine where in this case, we have to just think about the original cosine function. So 4 is multiplied to secant function, not cosine function. So cosine starts at the maximum and then it follows the obvious wave pattern, right? Yeah, so whenever that cosine function becomes, this is y equals cosine of 2 pi x. And whenever cosine becomes 0, we will draw the vertical line. So we will draw the vertical asymptote here and here and here and so on. Then we will use the local maximum and local minimum because of this 4 multiplied to secant. So instead of sharing this maximum point, the minimum, local minimum becomes 4. And local maximum becomes 4, and local minimum becomes -4, and so on, right? So I already explained that it should be a flipped position with the vertical asymptote. So it will look like this. In WebAssign, I believe all of those problems are multiple choice problems. I believe it's important to identify what the vertical asymptotes are and what the minimum and maximum is, whether this is flipped in this way or this way, and so on, when you choose the correct answer. Any question? The next one is about cosecant function. We will go through very similar process. This time we think about graph of y equals cosecant of x, that is defined as 1 over sine of x. So this is a fraction, and then what? Just a moment, I missed the questions in chat box. So how did we get the asymptotes? What time is it now? So it's quite a while. Yeah, so how did we get the asymptotes? And asymptotes happens whenever the denominator becomes 0, because 1 over 0 is undefined. Whenever that is undefined, we have vertical asymptotes, right? I said cosine value becomes smaller and smaller, that is 0.1, 0.01, 0.001, and then when we think about the reciprocal, it becomes 10, 100, 1000. So it will increase rapidly, but that is not defined here because that is undefined. And so this graph will rapidly increase, but it will never cross this vertical line. So what I said was whenever cosine becomes 0, the vertical asymptote happen. And what I explained was when you think about the unit circle, this point and this point, x value equals 0 and y value equals 1, x value equals 0, y value equals 0. This is cosine value. Cosine of theta is 0 whenever that is pi over 2, 3 pi over 2. So odd multiple of pi over 2. So this is how it comes from. So are you still confused about why vertical asymptote happens? Okay, and then the next question is why are the vertical asymptote every 1/2 instead of 1 over 4? Did what did I say? Vertical asymptote. So what I said was so depending on the point of view, I can say that vertical asymptote will happen every 1/2. But the first vertical asymptote happens at 1/4 because cosine value becomes 0 at 1/4. And then the next one is not the vertical asymptote. When you add 1/2, we will have another vertical asymptote. And so vertical asymptote happens every 1/2, but the first vertical asymptote happens at 1/4 because cosine value becomes 0 at that point. Did you understand? So let's go to the cosecant. Cosecant x is 1/sine. Our reasoning will be exactly the same. So whenever sine value equals 0, we have 0 or 1/0, which is undefined. So whenever that is undefined, this fraction function will have vertical asymptote because of the same reasoning. So domain is all real numbers except whenever sine value equals to 0. Whenever sine value equals 0, that means n times pi. You can think about the unit circle. And again, this one is this time 1, 0. And this is -1, 0. And these 0 are sine of 0 and sine of pi, and so on. Sine of 2 pi will be here, 3 pi is here, and so that is an integer multiple of pi. So domain is all real numbers except n times pi, when n is integer. Whenever we have places where the function is undefined, I said we have vertical asymptotes. Both vertical asymptotes are x equals n times pi. This is an equation of the function, vertical line, right? So we will follow through it. So whenever sine of x equals 0, let's graph it. We graph a sine function first that is bounded between 1 and -1. So sine function start at 0 and go up and down like this. This is y equals sine of x. We are considering the reciprocal function, so we do the same thing. Whenever sine value becomes 0, we will draw the vertical asymptote like this. And then, so 1/1, they will share this point. 1/-1 is this point. They will share this point and this point and this point. And then we have to flip it, right? But without crossing the vertical asymptotes. Like this. That is the graph of cosecant. So y equals cosecant of x is like this, shifted position. And then we think about the range. Range is the same as secant function. So that becomes negative infinity to -1, union 1 to infinity. And then period is the same as the sine function. So that is 2 pi. And sine function is odd function. So cosecant function is odd function. So cosecant of negative x equals, it was 1 over sine of negative x. So that is 1 over minus sine of x. So that is what? Minus cosecant of x, right? So why is that? Because, well, it is pi over 2. This becomes negative pi over 2. This was 1 and this was -1 and so on, right? And so when you draw the line which passes through 0, the point will be on the opposite side of x-axis. And so that just means if you switch the sign of the input value, then output value will switch in the sign. This one? Are you ready? Let's go to the next problem. The next problem is find the period of y equals 3 times cosecant of pi over 2x and graph it. As we have been doing, we will think about the period and then key points instead of thinking about the amplitude. We will think about local maximum and local minimum. So period is 2 pi over 2, which is 2 pi times 2 over pi. So these two will cancel each other. So this is 4. And key points will be from 0 to 4. And it'll subdivide into equal length intervals. So it'll be 1, 2, 3, 4. And because of this 3, local maximum will be 3 and local minimum is -3. Yeah, so this is -1. It includes -1. So let's draw the sine graph and then let's flip it. So we will bound with 3 and -3 for 3 times cosecant function like this. This is 3. This is -3. But we have to start with the sine function. Sine function is bounded by 1 and -1. This is -1. This is 1. And 1, 2, 3, 4, 5, -1, -2, -3, and so on. This time we are thinking about the sine function. We start at the origin and then we draw the obvious wave pattern like this. And then we completed the graph of y equals sine of pi over 2x. And then we are thinking about the reciprocal function. Therefore, after you draw the original graph, you have to draw the vertical asymptote first. So this is one of the vertical asymptotes, and the next vertical asymptote happens at 2 and 4 and so on. And then we will identify the local minimum and local maximum. So 3 times 1 over sine. So we will have here and here and here, here like this. And then all you have to do is flipping, right? Like this. So that is y equals 3 times cosecant of pi over 2x. Any question? Yeah. Right. Yeah, so you're talking about this one, right? Yeah, this is vertical asymptote because sine value is 0, right? Any other question? That's it for the graph of OL6 function. The next topic is about inverse trigonometric functions and their graphs. Let's go back to the college algebra class. In college algebra class, you learned horizontal line test. So let me ask you, which function is one-to-one? Is this one-to-one? Or is this one-to-one? What is horizontal line test? Horizontal line test tells us that when you draw the random horizontal line like this, wherever that is, the function is one-to-one if the horizontal line hit the graph at most one point. So this passes the horizontal line test, but this doesn't pass the horizontal line test because at these points, the line will hit the graph at 2 points. So this is not. So this is one-to-one. This is not one-to-one because it meets at more than 1 point. So horizontal line test initially tests whether the given function is one-to-one or not, but the result of the horizontal line test implies whether the given function has inverse function. So in this case, one-to-one, it has inverse function. Inverse function means the function defined by switching x and y values, so input and output. For this one, doesn't have inverse function. The reason I'm talking about a horizontal line test is to talk about the inverse function of the trigonometric function. Maybe you'd think about irony behind that, because if you think about any function, trigonometric function, let's consider y equals sine of x. This is y equals sine of x. And if you draw the horizontal line like this, then horizontal line hit the graph at infinitely many points, which means it doesn't pass horizontal line test. So we can say that sine function is not one-to-one function. But the title of this section is about defining the inverse trigonometric function. The point here is the sine, cosine, every trigonometric functions are periodic function. And so we will use that feature to define the inverse function. So what I said was trigonometric function are one-to-one. Let me start with the inverse sine function. Before we define it, I will draw the sine function first. This is y equals sine of x. As I said, a sine function is not one-to-one function. So what we do will be, we will limit ourselves to the region where sine function is one-to-one. We always focus on the region where sine function is one-to-one nearby y-axis. So you can expand one-to-one region up to here, to the right, to the left, up to here, right? So we will define the inverse sine function in this region from negative pi over 2 to pi over 2. By looking at the angle value between 0 and pi over 2 is quadrant 1. Angle value between negative pi over 2 to 0 is quadrant 4. In quadrant 1 and quadrant 4, the sine function is 1-to-1. This is 1-to-1. So angle location in the quadrant is quadrant 1 and quadrant 4. Here, this is negative pi over 2. This is pi over 2. This is quadrant 1, and this is quadrant 4. So we define an inverse function of a sine function on negative pi over 2 and pi over 2. Yeah. So what I said was the angle value between negative pi over 2 to 0 is quadrant 4, right? Yeah, so quadrant 4 here. And 0 to pi over 2 is quadrant 1, right? Quadrant 1.
So just to make sure that like I'm getting it. So like pi over 2 to pi would be like quadrant 2.
What did you say? Pi over 2 to what?
Pi over 2 to pi.
Yeah, that would
be quadrant 2.
Right, because
Okay.
this is pi over 2, this is pi, right?
Oh, okay, I see that. Thank you.
Yeah. Did you understand? Yeah. So we know that we can define the sine function, the inverse sine function. So we have to develop the inverse sine function. So notation of inverse sine of x goes like this: y equals sine. Sine is the function name. Usually function name is one letter, but trigonometric function, it has 3 letters, but that is the function name. So inverse means inverse -1 power must be attached to the function, and then that means inverse, not 1 over. Say inverse x. And so what I was saying was that doesn't mean not 1 over sine of x. This one is the inverse sine of x. And then, well, if it is confusing, then some people will use that as arc sine. Arc sine of x. So read arc sine of x. That means inverse sine function. We defined the inverse sine function. What does that mean? We switched the input and output function. So when we denote y equals sine inverse of x, that means if and only if sine value of y equals x. So we switch it input and output value, and so 1 should be the number between -1 and 1. And then we are looking for the angle between -pi/2 to pi/2, whose value, angle, sine value of that angle becomes x. And so that's what is written here. The range of y equals sine inverse of x, inverse function, is from -pi/2 to pi/2. We discussed the quadrant 4 and quadrant 1, and that was how we restricted the domain when we define inverse sine function. Now we switch it input and output, so domain will become the range of inverse sine. And domain is the output value of sine, right? So domain of inverse function will be from -1 to 1, right? Let me graph inverse sine function. Graph of y equals sine inverse of x. We know that the domain is -1 to 1 and range is -π/2 to π/2. The graph will be confined in this rectangular box. So what should you do? We think about changing the input and output. We know that sine of 0 equals to 0. What does that mean? That implies sine inverse of 0 equals 0. So it passes here. And the sine of π/2 equals 1. That's we already know. So sine inverse of 1 becomes π/2. So sine inverse of 1 is π/2. So it passes here. And the sine of -π/2 equals -1. Therefore, sine inverse of -1 is -π/2, right? So it goes like this, but it is not the straight line. What happens here is we switch it input and output because that is the inverse function. That means we switch it x and y value. The wave goes like this, and when we switch it x and y value, we will eventually get this type of wave, which is sticking to y-axis, right? Because we just rotate it. So it is the part of the wave. And so you will think about the first wave, and if you extend it, then you will just draw the arch like this. And then for this one, curve will go like this, and then it goes like this, right? If you just keep switching x and y value, but we don't think about what happens outside of -1 and 1. So graph of sine inverse looks like this. Now we learned the notion of inverse sine, and we wanna evaluate because that is a function. Find the exact value if it is defined. The first question is about sine inverse of 1. I think the best way to solve the problem is just to follow through the logical step from the definition. So sine inverse of 1 means we are looking for the angle theta, which stays between -π/2 to π/2. When we evaluate angle theta, the value must be 1. If you cannot remember this range, then what you will do will be you will just draw the picture of sine, graph of sine, like this. And then you realize that sine function is 1-to-1 between -π/2 to π/2. And then this one is 1 and this one is -1. This one was y equals sine of x And we are looking for the angle between negative pi over 2 to pi over 2. And we have to go down like this, right? So this is pi over 2. Therefore, we can say that theta equals pi over 2. Any question? The second question is a sine inverse of negative square root of 2 over 2. We will go through the same logical step. So sine inverse of negative square root of 2 over 2 can be written as theta. Theta must be the angle between minus pi over 2 to pi over 2. So when we relate that with the quadrant, this is negative pi over 2, this is pi over 2, this is 0. And then the angle was located in this region, right? And then we can clarify more because sine inverse of negative square root of 2 over 2 equals theta. That means sine of theta is negative square root of 2 over 2. So sine value is negative when y values are negative. So you have to draw the angle in the fourth quadrant. The next thing we have to do is we have to figure out the reference angle. How can we do this? Just so we already know that this value equals negative 1 over square root of 2, because we've been using the reference triangle over and over again. So we know that the reference angle for that is pi over 4, right? This is pi over 4. But that angle is in the fourth quadrant. So we go the other way, and then this angle is minus pi over 4. So we can say that sine of negative pi over 4 equals negative square root of 2 over 2. Therefore, theta equals minus pi over 4. Any question? So which part? Second, this one? Yeah, so you wonder why this happens, right? Right. So let's go straight forward. So negative square root of 2 over 2. We go opposite, so derationalize. So square root of 2 over 2. We multiply by square root of 2 over 2. Square root of 2 over 2 over square root of 2. So multiply the same thing. Then we will have minus 2 over 2 times square root of 2. Those will cancel each other. So that is negative 1 over square root of 2, right? So am I answering your question or something else? Okay, so this one is negative 1 over square root of 2. We are looking for the reference angle, right? So this value is particularly related to 45, 45, 90-degree triangle, right? And the value is 1 square root of 2 pi over 4. Okay, so the reference angle is pi over 4. Did you understand? Yeah. And then do you need more? Okay. Yeah, because this is negative value, sine value is negative, so I locate the angle in the fourth quadrant. Because sine value is negative, that means sine is defined as y over r. R is always positive, y must be negative. And so the angle must be located in the fourth quadrant, right?
Yeah, so the theta would also follow the original sine was, so it's that, so it's also.
Right. So, yeah.
Last minute, we saw for side. So now we're kind of doing the opposite.
Right. Yeah. Yeah. So of course, the inverse function is opposite. Yeah.
So when you see like inverse function like that, it's like you should be like, okay, I need to find like theta, like the reference angle, basically.
Right. Yeah. So the algorithm of solving this one is well, this is the sine function's value. And then what you have to do is you will firstly figure out what the range was, and then you will just shade it, and then you will locate the angle depending on the whether that is positive or negative. That's what I did. And then we have to think about the exact angle value. So for that part, we have to use the reference triangle, or we sometimes use this graph. So it'll go always just reference the triangle or graph.
Thank you.
But sometimes they will, the website will ask you to use calculator, and sometimes that can be a little bit elusive. The examples will be presented later. Yes. Right, because that is not one-to-one, so we will limit ourselves to where the sine function is one-to-one, nearby y-axis, and the principle will be the same with cosine, the inverse cosine and inverse tangent and so on. So am I answering your question or? Yeah. Right. You just start at y-axis. Let's say just you forgot what the range of inverse sine is, and then you will draw the graph, and then you will extend like this to the maximum region where sine is one-to-one, because it goes down and then it is not one-to-one, right? And that region is from negative pi over 2 to pi over 2. Did you understand what I was saying? Was that after you cross this line, you will have hit the 2 points, right? And so you cannot extend further here, and you cannot extend further here. So the maximum region is negative pi over 2 to pi over 2. Clear or? Yeah. Any other question? Okay, so next one is about using calculator. Hopefully I brought a calculator. I might not have. Oh, yeah, I brought it. The next question is use a calculator in radian mode to find an approximate value of the expression correct to 5 decimal places if it is defined. The first question is sine inverse of 2/3. So let's learn about how to do it. 2 divided by 3 equals 0.666. And then inverse sine. So second sine. So that is about what is I think the mode is wrong. It should be radial mode. So where is the mode? Yeah, here. I cannot see. Yeah, this is radial mode. So 2 divided by 3 and then inverse sine, green button and sine. So that is approximately 0.72973, right? So second question is about sine inverse of -2/9. So this one is 2/9 and then plus or minus and 6 sine, the inverse sine. So that's approximately -0.22409. So what's important here is you put the fraction first, and then the second layer you will put negative sign, and then you will put inverse sign, green button, and sign. Okay? So let me talk about inverse function property. When we combine the inverse sine with a sine function, that equals x, just an identity function. But we limited ourselves to a small region. So that happens only if x stays between -pi/2 to pi/2. That's exactly where we were considering that. So this is quite a subtle property. So if x doesn't belong to -pi/2 and pi/2, then sine inverse of sine of x is an angle between -pi/2 and pi/2 with the same reference angle and the same sine. What is important here? The same reference angle and same sine, but we have to put the angle back to the the region we are thinking about, negative pi over 2 to pi over 2. If you don't see the example, then it is very difficult to understand what is going on. So next time on Thursday, I will present the example, and I will talk about this again. So see you on Thursday through Zoom. Yeah. So this one? This one? Yeah, 2 over 3. So 2 divided by 3, and then you have to evaluate, right? Because, and then make sure that that is in radian mode. And then, so we are thinking about sine inverse, and so that is second sine, right? The grade will be unlocked after the second exam. If you look at the frequently asked question, then I already explained in details. Because at the beginning of the semester, some students might not be able to take the exam. And then their score will be in the F range, and which is really bad. And so that affected other students' psychology greatly in the past. And so I don't show the exam score after the, I mean, total grade after the first exam. But in the frequently asked question, I wrote how you calculate your own grade based on the record you have. And so if you follow it, then you will be able to calculate your own course total. Do you have any other question?